2. Okay, now that we've talked about area and looked at an example, let's get into sectors. So a sector is a part of the interior of the circle bound by an arc and 2 radii. So it's bound by an arc, so here's the arc, and 2 radii. Here's one radius, here's another radius. So it's bound by those, I guess, 3 things, and it can't go past it. So the sector is everything inside of it. The sector, let me color this. Maybe on your screen it's not showing up yet, I'm not sure. But this, everything in this little pizza slice, this is a sector. It's everything in it. Now, what do you notice? Remember I said that the area was everything bound by the circle, everything I'm shading, or I'm going to shade right now. Hopefully you'll see it after I shade. I'm not sure if you can see it right now as I'm shading. Remember, the area is everything bound by the circle. And what do you notice? The sector is only a part of it. It's only a fraction of the actual area. Okay, so the sector is a part of the interior of the circle. It's bound by an arc and 2 radii, and it's a fraction of the area of the circle. This should remind you of what we talked about in 5.7, where we talked about arc length, circumference, and how the arc was only a part of the circumference. So what we did in 5.7 is actually very similar to calculating the area of a sector. So I put it here side by side so we can sort of see the similarities between the two. Because we already know how to find arc length, right? And now we're trying to learn how to find the area of a sector. So let's go ahead and do that. So first, let's remind ourselves how we did arc length, right? We wanted to measure the arc length not in degrees, but in units of length, right? Because it's curved right now, but if you were to straighten it out and put on a ruler, you can measure its length. So how do we do that without actually putting it on a ruler? Well, remember, we said that the arc was a fraction of the circumference, right? And let's pretend this arc angle is 100 degrees, something like that. And then, remember, we had to find what of the circumference, how much of it is made up by the arc, right? So we wanted to find some fraction. So what did we do? We knew that the arc was 100 degrees because the central angle was 100 degrees. So arc AB is also 100 degrees. And then we just divided it by the total degrees of the circle, which is 360. And that told us, it would give us a fraction, and it would tell us how much the arc makes up of, how much of the arc is made up of the circumference. How much of the circumference is made up by the arc, okay? Now, after we found the fraction, we also had to multiply it by the circumference, right? And then that would just give us some arc length. I'm not going to solve it because we did a lot of it in 5.7. So if you're confused, please go back and watch that video. So what you see for arc length is we took some fraction and we just multiplied it by the circumference, because the circumference again is just the distance around the circle. So what do you think we're going to do to find the area of a sector? It's actually very similar. Can you already see what we're going to do? What we're going to do is that it's very much the same. We're going to find the fraction and we're going to multiply it not by the circumference this time, but by the area, because it's only taking up a part of the circle's full area, okay? So in this case, let's say that this is 100 degrees. So 100 degrees divided by 360 times the area. I don't know, I guess I'll say the area is 100 inches squared. And if you do that math, I need a calculator. If you do that math, you would get 27.78 inches squared. So this is the area of the sector. 27.78 is the area of the sector, right? So you see how they're both very similar. It's the only difference is that one is the circumference, one is the area, but the method to calculate it is very similar because the concepts are similar. Because the sector only makes up a fraction of the area and the arc length only makes up a fraction of the circumference. So let's look into an example. What is the area of the sector? Well, first we have to write, what did we need? Area of the sector. We needed some fraction, 360 degrees, where the numerator was the arc, the measure of the arc. So let's say this arc is AB. AB. This M just means measure, okay? So the value of the arc. So we needed some fraction, and remember, we multiplied it by the area. Oops, I should not have, I say AC, area of circle, and then this, AS, area of sector. There you go. These are subscripts. Wait, yes, subscripts. Okay, so what is the measure of arc AB? Well, we see the central angle is 110, so the measure of arc AB is 110. So you can plug that in. And now what is the area? Remember the area of the circle, I'm going to write down here, is pi r squared, where r is the radius, and we see that it's 6. 6 squared is 36, so 36 pi. Okay, so now we just multiply it. And if we use our calculator, which I'm going to do right now, then we should get that the area of the sector is 34.56 centimeters squared. Why is it squared? Because it's area. Okay, so that's our answer. Now let's look at a somewhat more challenging question. Sorry, I keep zooming. Okay, that's all you need to see. What is the measure of the central angle if the sector area is 39.1 inches squared? So let's just write down what we know. 39.1 inches squared. Well, again, what did we need? Well, we said that to find the sector area, AS, we needed the fraction that the sector made up. Wait, I always get myself confused. Of the area, how much of it is made up by the sector? That is what our fraction's representing, right? Okay, sorry, I should label my arcs. There you go. And then we multiplied it by the area of the circle. So this is our general equation, and we can just plug in what we know. We already know the area of the sector, so let's plug it in, 39.1. Do we know the measure of arc AB? No, because the measure of arc AB is the same as the central angle, and the question is asking us to find the central angle, so we don't know it. So let's just leave this alone. 360. Do we know the area of the circle? No, but we can solve for it because we have what we need. Area of the circle is pi r squared, where radius is 8 inches. So that should give us 64 pi. Oops, why does this say plus? Sorry, there you go. Times 64 pi. Okay, so now measure of arc AB, which is why I said MAB, is our unknown. We just treat it like any variable. Treat it like any variable x, r, it's just some variable. Something to represent something. So we'll just treat it the same. It's our unknown, we don't know what it is. How do we solve for unknowns with algebraic equations? We just get it by itself. Let's get it by itself. This 64 is sort of coupled with this. So let's get rid of that. How do we do that? Divide this entire side by 64 pi. Cancels out, and then you have to divide both. You have to do the same thing to both sides because we have an equal sign. So what is 39.1 divided by 64 pi? I don't know, let me ask my calculator. So that is 0.1945. And then we have MAB over 360. We're not done yet because AB is not by itself. So now we just multiply both sides by 360. And then we'll cancel it out. And then what is that times 360? It is 70. 70. So now, MAB is 70. 71. It's 70 degrees because we're measuring our arc in degrees. So if our arc is 70 degrees, if our minor arc is 70 degrees, then our central angle is also 70 degrees because the minor arc has the same measure as the central angle. So that is our answer.